Welcome back to Think What If. In 2006, scientists across the globe sounded the alarm, a sudden, dangerous surge in atmospheric methane. This potent greenhouse gas, even more effective at trapping heat than carbon dioxide, has been on the rise ever since, acting like an ever-thickening blanket around our planet. While initially the blame was placed on human activity, a deeper look revealed something far more mysterious, originating from deep within the Earth itself. What's causing this dramatic increase in methane? And why now? How do scientists even detect it? Most importantly, is this a sign of impending doom or a fundamental shift in Earth's climate? For eons, scientists have understood that methane spikes follow a predictable pattern, occurring roughly every 100,000 years. We know this from analyzing ice cores from places like Antarctica and Greenland. Think of these ice cores as Earth's historical diary, with layers of snow trapping tiny air bubbles that preserve atmospheric conditions for hundreds of thousands of years. These records show that these massive methane increases typically mark the end of an ice age, ushering in a warming period that melts glaciers and reshapes our world. But here's the mind-boggling part. The last time methane levels were this high was 12,000 years ago, signaling the end of the last ice age. So why are we seeing a similar spike so much sooner? To understand this, we need to journey back through Earth's geological timeline. We are currently in the Quaternary period, spanning the last 2.5 million years. This era includes the Pleistocene epoch, from 2.5 million to 12,000 years ago, a time of repeated ice ages, human evolution, and the extinction of giants like the mammoth. Following that is the Holocene epoch, beginning 12,000 years ago and continuing today, a relatively warmer, more stable period that allowed human civilization to flourish. Technically, we're still in an ice age because ice caps remain at the poles. An ice age only truly concludes when all polar ice has vanished. So, what triggers these warming phases? Scientists point to the Milankovitch cycles, three key factors influencing Earth's climate. Eccentricity. Earth's orbit around the Sun isn't a perfect circle. It varies in shape, sometimes bringing us closer to the Sun and increasing solar energy over about 100,000 years. Axial tilt, obliquity. Our planet's tilt on its axis fluctuates between 22.1 degrees and 24.5 degrees over roughly 41,000 years. A greater tilt means more intense summer heat at the poles, accelerating ice melt. Precession. Earth's axis wobbles like a spinning top, altering the timing of seasons over 19,000 to 23,000 years. When these cycles align, they create warming periods. Ice, which normally reflects sunlight, melts, revealing darker land and oceans that absorb more heat, creating a feedback loop. As Earth warms, trapped gases like CO2 and methane are released from permafrost and oceans, amplifying the warming. But if this cycle occurred 12,000 years ago, what explains the 2006 methane spike? Human-caused methane emissions from the natural gas industry had been increasing since the 1900s, but began to stabilize by 1990. So what changed in 2006? Methane isn't solely a human problem. It's also naturally produced in Earth's soils and oceans, often trapped beneath permafrost or in underwater sediments. As these thaw, methane is released. Thanks to advanced satellite technology, scientists can now pinpoint these sources. Satellites emit a laser beam that methane specifically absorbs. If the reflected light is weaker, it indicates methane presence. NASA, for instance, detected a colossal 3-mile-wide methane cloud over a landfill in Iran, spewing an astonishing amount of methane annually, equivalent to 180 jumbo jets. Even larger emissions were found in Turkmenistan, with 12 gas field locations releasing hundreds of kilograms of methane per hour. However, the real culprit behind the 2006 surge might be more widespread. Scientists believe natural emissions from thawing permafrost and decomposing ancient organic matter in Arctic forests are also significant contributors. This is methane that, unlike landfill gas, cannot be captured or utilized. While some advanced landfills capture methane for energy, converting it into less harmful CO2, methane persists in the atmosphere for about a decade before breaking down. Here's the truly alarming part. Even throughout Earth's vast history, we've never witnessed such elevated methane levels during a period that isn't an ice age. This could signal that Earth is entering an entirely new, uncharted phase. The truth is, scientists lack historical precedent for methane levels rising this rapidly after such a short interval since the last ice age. We also don't know the ultimate peak of these levels or the precise balance between natural and human factors. If this is a purely natural phenomenon, we might be powerless to stop it. Is the ice age officially ending, or are we heading into a new one? The answer remains uncertain. What do you think about this unprecedented methane surge? Let us know your thoughts in the comments below. Don't forget to like this video, share it with your friends, and subscribe to Think What If for more fascinating explorations into the mysteries of our world. We'll see you next time.